Good afternoon. Great to see you again, or at least those that I can see. I'd like to tell you my conversion story. I love being at DARPA. DARPA is a place, like you heard, where it's not audacious, unheard of to say we're going to change the world. So I love being at DARPA, and I love being in STO, the Strategic Technology Office. But when I got to STO, I had the opportunity to see our portfolio. And we have an amazing portfolio, one of which would make you proud as an American. We have capabilities in sensing. We have capabilities in effects. We have some amazing capabilities, and many of these are so impactful and have the opportunity to change the conversation in so many ways that we protect them, and so we don't talk about them openly. But we also have a part of our portfolio that references, that invests in command, control, and communications. And when I joined the office, I was not naturally drawn to this area of command, control, and communications. I thought this is adjacent to, but perhaps not critical to, what we want to do in changing the world and changing the conversation for national security, national defense. That was 6 months ago. I'm here proudly to outline some of our investments in command, control, and communications. And I'll emphasize communications here, but I want to take some time at the beginning to tell you about my conversion story to realize why we need command, control, and communications so desperately within STO and within our portfolio writ large. And the reason is because in STO, we want to scale. If you want to scale, you want to change it all for as little investment as possible, for as few platforms, as few technology insertions. And so to do that, you really want to invest in that capability that's exponential, that grows exponentially, not linearly. Well, I believe now command, control, and communications are a core investment portfolio for us to achieve exponential results. And here's what I mean. Let me start by saying, typically we refer to command and control as C2. If you heard it abbreviated as C2, then you know as soon as I say C2, you think communications. It's amazing, right? It stands for command and control, and yet when you abbreviate it C2, it somehow means something different. And I feel that viscerally because you might be aware I was fortunate to start my career as an Army officer. And command and control means something very distinct. It is what defines our Western way of war. Command is the definition of our intent. It's a mission command. We define the intent, the task and purpose, the rough legal, moral, ethical guidelines, and allow the smallest unit to operate with great autonomy. And I use that term intentionally because we're going to talk about autonomy from a technical place, but I believe it has a place within human operations as well as platform operations. And then control is this feedback loop where the lowest unit feeds back in this control scheme that says, here's how it's going, here are the emergent opportunities, and here's how I can exploit what I am seeing locally. That's a powerful construct. It is not hierarchical, it is emergent. It is the definition of a complex adaptive system. So this command and control allows you to have positive emergent behavior. Truly exponential. Linear is hierarchical. Exponential is leveraging the unforeseen. And then communications are absolutely essential. You can't have command and control without some ability to communicate. That does not mean we necessarily need the size pipes that bring us full motion video from the forward edge to wherever. But it does mean we have to have some degree of resilient, mission-informed, mission-driven communications. So my conversion story is we need to invest significantly in command, control, and communications if we want to make a maximum impact. But I'm here to talk about part of that story, and that part of that story is really key to understand the role of the commercial space in communications, and I'll focus largely on communications. I'll talk some about autonomy. The commercial role within communications, and how do we leverage their capability, their technology, and their technology development. How do we leverage their infrastructure? And then, the last I'll end with is some of our investments that are seeking to augment the open source community. because we believe now is the time to invest in the open source community because we believe it'll have significant returns for us. So Confluence of Communications is really the story of the commercial space working with the military space. But before I get there, I want to highlight some of what you might consider STO to be known for, and then perhaps challenge some of your assumptions. So the Strategic Technology Office, STO, is known as a systems office because we bring together systems. We bring together systems that collaboratively sense, and we sense in all domains, as you see, in the air domain, in the ground domain, the subsurface, surface, the space domain. We sense in these domains, but the more you can sense collaboratively, the more information and the more understanding, those are not synonymous, the more understanding you can get. And so systems sense better than individual platforms. Similarly, once we sense, we want to make some decision and have some effect. But I moved too quickly because the highlighted platforms here have an empowered human decision maker, and I don't want to skip past the central role of the empowered human decision maker. We want to sense in such a way that the human can make the best decision possible. And what that means is not just data and it's not just information, but truly contextual understanding, because our legal, moral, ethical, importantly, our ethical decisions are those that are informed by the broadest context possible. So how do we sense broadly to paint a contextual understanding that can help a human decision maker make the best decision she can? And then we take some effect. And again, those effects benefit from a systems approach, and that's what STO is famous for. But I removed what you might consider the lightning bolts that connect all of these systems, because I think it's important to start from a command and control perspective first and say, what do we want from a command and control perspective that allows autonomy to maximize mission effectiveness? And notice I didn't say machine autonomy or human autonomy because it's a growth area for us. And so I want to take a different approach to motivate this just briefly. As I said, I was fortunate to start my career as an Army officer, and I flew what my children call God's machine, that is the H-64 Apache. The Apache helicopter is an amazing machine, but you never fly one on its own. You always fly in pairs. You always fly in buddy teams because you're more capable as a team. But then as a lieutenant, I had the audacious opportunity to fly in teams of 4, a platoon. And why 4? It's the same argument that 4 is exponentially better than 2. If I had 4 ships, I could not only protect ourselves and look for targets, I could also call in field artillery. And increasingly, we can call in UAS. You can't do that with a single buddy team, but you can leverage a great deal of complexity imposed on our adversary when you have more, but it requires communication. So we're back to a place where communications are key within this construct, more broader construct of command, control, and communications. But as I said, the confluence of communications really needs to be a story about the role of commercial enterprise. What I depict here are 2 roadmaps in all areas of communications, from space to autonomy. And you see in these timelines some DARPA investments and some commercial investments. And I want to address right off the bat the black line, the DARPA investment line. It sometimes can look like we have some roadmap. But I'm here to tell you that roadmap is only retrospective. At the time, we seek to exploit whatever we can do today that we couldn't do yesterday. And so much of what you've heard is, please let us know what we can do today that we couldn't do yesterday that we should exploit. So as we look back, we see these long arcs that come together. And what's not clear, and what I don't want this graphic to depict, but allow me to unpack, is some of the interactions between the commercial space and the military space. Because sometimes we adapt commercial investment, but sometimes we make additions to, contributions to the state of the art that then bring about new opportunities. Of course, I've got to skip to the middle. The internet was predated by Project Mech, the ARPANET, and TCP/IP, which were DARPA investments. So right off the bat, let's take credit for some key pivotal DARPA investments that gave birth to a capability we refer to as the internet. But then following down that stream, the DARPA agent markup language leveraged investments from XML, so from the commercial open source space, to DARPA, and then returned to lay some of the foundations that we now leverage in the commercial space for semantic web. But let me return to the top in this space domain, some key early investments in DARPASat, PicoSat, that led to some of the foundations, some of the capabilities that led to the tremendous proliferated low Earth orbit P-LEO constellations we see in the commercial space. In the terrestrial wireless, back in the early days of my time in the military, we used frequency hopping in the SINGARS radio, if you're familiar. We used spread spectrum approaches in order to try to avoid interference, try to have high bandwidth. And those capabilities informed investments that the military referred to as DSSS, that the commercial space refers to as CDMA. And there's a small company that leveraged those technical innovations and gave birth to much of what we refer to as a cellular network. That small company, of course, was Qualcomm, that leveraged early DARPA investments and military investments to great effect in the commercial space. We'll refer to the optical domain momentarily. The OISL we'll refer to shortly. That's an optical intersatellite link. We've talked about networking. Digital engineering is fascinating to see how we can design an entire platform digitally before bending metal. And so one of the open questions is that something that we should extend and exploit? We'll talk about open source and augmented reality. But I want to end with autonomy, because you can see I'm using autonomy in a very broad way. Because when you refer to autonomy, then we're going to refer to Shaky the robot. How does Shaky the robot refer to communications? Our work on the Grand Challenge and the Urban Grand Challenge, those were all examples of platforms that understood their environment to some degree and made decisions. In a similar way, I hope to convince you that the time is now for communications systems to understand their local RF environment and then respond. And so the story of the Confluence of Communications is all about this interplay between military investments that in some cases adapt, in some cases leverage the commercial space, and then at the end, in some cases, give back to the open source community. So I want to walk through some of our investments in a variety of areas, and I'll start with some investments in autonomy. And the Mission Integrated Network Control Program seeks to bring about a degree of resilience and mission-informed design that is absolutely essential for operations, but unfortunately we don't see available now. So back to my early days, we had Army networks that allowed me to talk to Army units, but that didn't scale to Navy units and joint operations and fast movers and the variety of operations that we now consider absolutely essential. It's because these networks were built in a stovepiped way and had their well-defined use cases, and now we're operating outside those use cases. Well, in the civilian space, the 2G network gave birth to the 3G and the 4G and the 5G network. We have these tremendous capabilities, but these were backwards compatible and allowed us to build upon each other in a way that the services, Army, Navy, Air Force, were not. And so what the MINC program hopes to do is two things. One, it hopes to serve as a means to bring together various previously stovepipe networks to allow communications from, say, the ground through an air, maybe even an overhead asset, to create data links to where it's needed. And in some cases, that requires things to change in autonomous ways. And so first I have to understand the environment. As I said, autonomy is about understanding the environment. Fortunate to follow a panel that discussed that. Understanding the environment and then responding, adapting. So if I understand the RF environment, and if I understand what data links and networks are available, then I can adapt my path. But importantly, what if I could move platforms? And you see that here. What if I could move an overhead platform or an air platform in order to create connectivity? That does not exist now, where a user from one network could move a platform in another. But imagine the connectivity and the resilience that could provide. And the second capability we seek to bring about is a true mission-informed design. A mission-informed design says not all bits of data are created equal. Let me give you an example. when you're in the Apache and engaging a target, if you can observe the target, you want an update with very low latency just before you engage. But the reason the Apache is such an incredible machine is you don't have to be in direct contact. You could be behind a terrain feature. You could be masked. And in that case, perhaps I'm in an environment where I can benefit from some latency. I don't need the same degree of connectivity. And so in a similar way, across this joint network, not all data is created equal, so not all needs the same latency. So can we architect this such that the data that needs to have low latency benefits from an approach that allows that? In a similar way, the RunDMC program seeks to deliver resilience. It also seeks to deliver a really cool name, not the last one that we'll see. The Resilient Networked Distributed Mosaic Communications program is about providing resiliency. This resiliency is built on the back of significant commercial investment in multi-input, multi-output, MIMO. And if you recall from where you ate lunch, there were routers all around the periphery, had multiple antennas. That is a MIMO system, multi-input, multi-output. And the reason that we're at a point that we can do such incredible things as multi-input, multi-output is because radios are cheap now. Signal processing is cheap, transceivers are cheap, and so now we can leverage inexpensive capability to provide a wide set of capabilities. For the military, what that means is I can provide resilience even in the face of interference or jamming. And so I can literally have exponential capability when I pull together distributed tiles. We call them tiles or apertures, transceivers. If I created a cloud of transceivers, of transmitters, those of you that are electrical engineers or otherwise understand that the maximum yield potential is an n squared. If I have n transceivers, I can have n squared capability to communicate, as I depict here, with some overhead asset. And then on receive, I have the potential of an n squared gain as well. So the previous approach was let me get a bigger aperture and a bigger amplifier. Both of those have obviously size, weight, and power implications, cost implications. And here we're saying, well, what if we take a different approach? What if we use inexpensive capabilities, has significant technical challenges in terms of the phase coherence, et cetera, but then I could orient a main beam in a direction I want, but also direct my nulls in a direction I want, and I can be very adaptive in the face of a dynamic environment. And that's really what we want to deliver, is resilience in the face of a dynamic environment. Speaking of a dynamic environment, we often have members of the National Security Force, members of the military, operate in cellular environments, in others' networks. And in 5G, the 5G capabilities are incredible. It allows us, for the first time, to operate and potentially create a slice, create a network, create a tunnel that our military operators can operate within. The GECKO program, Generating Communications Channels to Operate, says we want to ensure that the traffic, the information we're sending through future 5G tunnels and slices, that information is not exploitable and maintains our privacy. So this is brand new. This is new to you. You will read about this soon. I would tell you more about it. I won't, because I want you to read all about it here soon. But look for the first special notice about this coming up momentarily. But you can tell that the GECKO program is about leveraging commercial infrastructure, but doing it securely, maintaining our security in the face of and benefiting from significant commercial investment. In a very similar way, the Space Bacon program seeks to deliver resilience and maximize commercial investment. Also seeks to one-up the RunDMC program in the cool name category. So there was a Bacon before a Space Bacon. The Bacon program was the Battlefield Airborne Communications node. And this was an airborne node, an aircraft that allowed anyone and on any network, whether on the ground or in the air, to communicate up to it, and then it was a translator. And it translated down to some other network, to some other user. That was in the RF, the radio frequency domain. In space, you have to talk about optics in the optics domain. You have to talk about that for a variety of reasons, but it creates some significant challenges when you look to be the translator. It creates challenges in terms of the speed of communication and some of the tracking mechanisms, et cetera. But if we could be a translator, then we could provide a degree of resilience that our military users do not enjoy right now. So imagine if we could leverage dissimilar proliferated LEO constellations like a Space Development Agency constellation, a Blackjack constellation, an Amazon constellation, a Starlink constellation. And what if we could link in other assets from other orbits to allow us to provide a resilient communications network? Well, that would require us to think hard about how to be this translator. Fortunately, we've done that hard thinking, and what we believe is there's a business case. There's a business case if we can provide 100 gigabits per second at less than 100 watts and at less than 100K per node, we could have select space bacon nodes, probably with the stickers attached, at key places that serve as translators. We don't need every platform, every spacecraft bus to have this, but key buses could and serve as this connectivity. We're talking about commercial and leveraging commercial in some cases and also extending commercial. In this case, one of the lessons of the Space Bacon program was if we're going to be successful, we have to think in terms of business. We also have to think in terms of the business case. And so if you're familiar with the Space Bacon acquisition approach, it said, let's start over from the federal acquisition regulation, the FAR-based approaches that require significant proposals and significant time and significant time to receive and draft and review them. What if we had a different approach? And what you saw in September when we launched the program, we asked performers to have a 5-page abstract, which we reviewed and allowed, and then that was the bar to entry, pretty low bar to entry, to start oral solicitations, an oral presentation that upon award, we paid $300K for performers to spend 3 months writing their proposal. And what I hope you hear is this is a different approach that matches the technology with the kind of performers that deliver at speed and scale that we want. So the Space Bacon program, not only a technical program, but I believe an innovation in the acquisition approach aligned to the kinds of industries and performers that we want to be part of the DARPA ecosystem. And then wrapping up, I want to discuss our contributions or the ways that we leverage the open source community. So there's a past effort in DARPA that created the domain of named data networking, and then we handed that off, transitioned it to the National Science Foundation, NSF. And NSF had several turns in academic research associated with it. And now we believe the time, and what we did in the SHARE program is take that academic and open source investment and extend it. The problem we have is that the coalition can't talk. When I was in Afghanistan, I could be sitting next to a coalition partner in a plywood shack, and I would send a message to someone from the UK, for example, and that message would go back to, say, DC, to a multi-domain server that confirmed that the content was available for or appropriate for a coalition partner to read, and then came all the way back to the other side of the plywood hut. And the question is, can we do better? And so in the SHARE program, we had approached 2 different technical challenges. The first was this decryption, and the second was doing so at scale. And the unique insight was that we could do both at the same time. And so what we demonstrated was an ability to port this hardware onto a handset, this ATAC handset, and it proliferates your messages, but not in either a direct way or a mass way, but rather in an intent-driven way. It's fascinating. You have some information suppliers and you have some information demanders, those that have a demand. And instead of updating routing tables in order to ensure that we have connectivity, what NDN says is proliferates, increase these supply nodes, these publication subscribe nodes, pub sub nodes, that shortens the communications channel, but allows you to do so at scale, rather than maintaining all the data traffic in order to publish to everyone or maintaining routing tables. And so demonstrating this at scale was unique, and now we give back to the open source community for their use in this demonstrated application of named data networking. And then finally, we want to leverage all of the commercial investment into 5G. And 5G is a phenomenal opportunity for the commercial space and the military space. And there's two parts of 5G. The first part is the radio access part, from the base stations to the handsets. And that's where you hear of 5G standards, and that's where you're aware of a great deal of the work. But the second half is going from the base station through routers, fiber, to another base station. And there, the infrastructure is, as you see on the left, is opaque, proprietary, and vertically integrated. And so while we can have, as I mentioned in the Gecko program, the ability to have a military slice, network, or tunnel, we're not sure that the information that we pass through there can't be exploited in some way. So we want to maintain our privacy. And so what we want is on the right, open, programmable, and secure. And so we could use the existing network, but we have security concerns. We could fund a government solution, but that would be massively expensive. Or we could, and we're doing the Ops 5G program, leverage the open source community. Now there are challenges. The open source community has some security guarantees, and that is very hard to add malicious code in the face of so many contributors, but we have to ensure that the software is 5G compliant. But if we can do so, then we can deliver what you see on the right. This open source software leverages fast development, uses non-US, US, and open source hardware to deliver capability for all, particularly those in national security. So now you're wondering, when is it time for your own conversion story? What can you do to get on board? I wanted to highlight some of the opportunities that we see. And again, I'm back to the theme of what can we do today that we couldn't do yesterday? And so, in the Internet of Things, we're wondering, what can we do today that we couldn't do yesterday? The Internet of Things is about massive connectivity and massive sensing. Well, maybe the connectivity is different because it's fixed rather than dynamic, as you saw in the Run DMC program, for example. But what does the proliferation of inexpensive but rather capable sensors mean for the military, mean for DARPA? We'd love for you to help us understand what that might mean. But one thing it means to me is the potential of understanding context. And the semantic web leverages context to try to deliver content that's appropriate for you, that's ideal for us as a consumer. Well, what does that mean as we think about sensor networks that want to deliver context so that an empowered human decision maker can make the best decision, the most ethical decision, as quickly as possible? And that motivates our interests in augmented reality. And so you're aware of the commercial opportunities within augmented reality. It's fascinating. And you're aware of the Army's work to leverage augmented reality for battlefield use. And one interest that we have is how can we do so in a systems of systems way? And I keep talking about an empowered human decision maker, but she might have to wade through a massive amount of data or information to try to reach some contextual understanding. So is augmented reality or virtual reality an approach that would allow us to gain traction on that problem to make decisions as quickly and as impactfully as possible? Digital engineering is a trend that we're watching and wondering, what does that mean for us? Certainly for the design of platforms, it's exciting. The Boeing 777 designed all digitally, fascinating, has real application for military development of platforms. But what does it mean for a system of systems? Perhaps it means that we have as-built understanding rather than as designed understanding of capabilities. And then non-terrestrial networking refers to our interests in off-board networking. Space bacon takes a big bite of that, pun intended. But what if Our interest in non-terrestrial networking includes communications from the lunar surface. Is now the time for us to invest in that? What capabilities, what breakthroughs, what paradigms would shift if we could do so? In many of these areas, you see us leveraging commercial investments, and in some cases, we are hoping to give back. But in many of these cases, the performers that would contribute, that could be part of some DARPA investment, are non-standard. Those that might not have worked with the military before. And there, I think we're challenged. We're challenged because we have an unvirtuous cycle. What I mean is, if you're a small business owner, you can't read a DARPA classified proposal. You can't read a classified proposal because you've never done classified work. You don't have a facility clearance. You don't have a facility clearance because you've never done government work, and you can't do government work because you can't read or write the proposal. And so we have this unvirtuous cycle that locks out some performers that might be able to contribute. And so we believe we have a new approach. We believe that there's an opportunity to break this unvirtuous cycle. And we believe that you're going to have to come to Washington State to hear more about it. But I appreciate this opportunity to talk about some of the challenges that we have in the military, but some of the ways that we are leveraging commercial infrastructure, adapting their capabilities, and providing resilient, mission-driven networking and communications capabilities to the military, to our soldiers, sailors, Marines, Guardians. With that, I'd love to hear your questions and thoughts about command, control, and communications writ large. I'm looking out as if you get to ask questions. Of course, you have to use the app. First question. Where do you see DARPA and commercial technology providers coming together in the future? That's a great question, and one that I believe has been a thread that I haven't made explicit throughout this discussion. I believe that the way that we solicit performers needs to align with the broader business case, and the way that we transition capability at the end of the program has to be in line as well. I think we could do more, exponentially more, if we have aligned incentives. So what am I saying? I'm saying that I think there are different types of transition opportunities for many of these programs because they lend themselves inherently to fast-moving, developing technology programs. And so I believe there are opportunities for programs like SHARE that I failed to highlight. SHARE is about cross-coalition communications, as I said. What I didn't share is that it relied on a DevOps development timeline, pipeline. We worked with operational users. The glimmer in my eye is that it's always great to work with users. It's always inspiring. It's always far more challenging than you predict because they demand a slightly different solution than you were expecting. But at the end of the day, we have a capability that absolutely addresses them and their needs. And so what we found is that there are programs that should, by design, solicit those performers that can excel in DevOps. And then the end state is a better understanding of the true problem for the military, but also a product line that could immediately be provided. Another transition path that we see is an as-a-service model. As-a-service says it's very hard for the services to transition DARPA capability. It's difficult for several fundamental reasons. The first reason is DARPA's job, if you've been here for the past 2 days, DARPA's job is to be disruptive. That means our job is to take a service roadmap and look at it differently. And so it's very hard for the services necessarily to adopt our capability. It's also hard because of the budgeting process that the services follow out of necessity, out of regulations. And so what we're seeing is a different approach. And as a service model says, I don't want to talk about a future program of record. What I actually want to talk about is a service that's commercially available that I could pay for. So now think Space Bacon. That's not a program of record. Rather, it's a service. It's a translator service. And so we see different transition models aligned with, and so we're thinking about transition from the beginning. It can certainly change, but we want to think more broadly about transition than just programs of record. The next question is, how are communications programs transitioning to the military? I'll give you one more, since that's a similar question to the first. In the Run DMC program, we're not chasing a program of record. We're actually providing, or the capability will transition to a better product line for those performers. And then those performers have an opportunity to go seek sales, perhaps to the military, perhaps to other aspects or elements of the national security community, perhaps to fire and police. But let's not chase, in this case, a program of record. Let's look at how do we make a better product line. And it's true to what I've discussed throughout, this thought of how can we adopt and then give back into the commercial space. Next question, what gaps are DARPA trying to address? We mentioned some toward the end, but those gaps are really questions. Those gaps are, what does this mean? What does the Internet of Things mean? Is there something that we can exploit? But I will give you one gap that I'd love to hear your thoughts, and perhaps it's a bit philosophical, but we need to develop a technical solution to continue to push on command and control. We should not be thinking of a world where we just communicate broadly across big pipes of data. We should do as much processing as we can locally, but that local processing would be improved if the processing understood the commander's intent, that command structure, because then it can give feedback, the control structure, that helps the commander appreciate the opportunities that exist within, that emerge within the dynamic environment. And so I think command and control as a construct deserves a relook. We have some efforts going on within STOW, within DARPA, within the services, but I think there's more that we could do to ensure that we communicate when we need to, what we need to, because every time we communicate, we're also become a target. And that's dissimilar to the commercial space, an important difference. As you develop fielded systems, what, if any, considerations are made within system design to better train future operators receiving the product? That's a great question. A couple answers. Within the SHARE program, I mentioned that we embraced a DevOps development paradigm. And so we lived, and in fact, in some cases, developed in the field to provide the best capability to the operators. As I said, I was able to spend my first career in the military, and my last tour before coming to DARPA was at West Point, where I was an instructor. And one of my former cadets was a captain in this unit and reached out. And so I can answer this question personally. He better understood how to use the system because of DevOps. And he also then pushed the system and said, wait. And I'm proud of this because I would think he learned something from my class. He said, wait, if you can do that, then you could do this. If you can be resilient in this mode, then you can scale, and we could talk about a different data stream altogether, for example. And so that is true DevOps, but it's also a key part of the answer that the operators in this case left with a true appreciation of the capabilities, but also how to make it sing, how to really use the capability to its fullest potential. And so I love working with warfighters because they never are satisfied with the status quo. Next question, can you speak more about breaking the unvirtuous cycle? If you can't speak to the plan you're rolling out in the future, can you discuss some of the elements that you think are required to disrupt that cycle? I can speak more about the unvirtuous cycle. I will choose not to speak about the unvirtuous cycle, except to say it's a vexing problem, and we're excited to roll out a plan that allows us to bring in non-standard performers. But know that this is a business case. This is not, this is an incubation case. This is short-lived. We don't want a capability that suddenly endures for all performers. What you will see are targeted opportunities to work with, and we provide the facilities and we provide the capabilities. So I guess I am talking about the unvirtuous cycle. For a period of time, and if during that period of time you don't find traction or you can't deliver, that's business. We'll move on to the next, but at least we provide an ability to break this unvirtuous cycle. And now we'll stop and move on to the next. All right, you talked about open source as well as using commercial infrastructure. Do you see DARPA moving forward to an open source future using COTS software, hardware, sticking with GOTS, or some combination? That's a trick question. It's a trick question because it's asking me about the future, and in DARPA, we take one step at a time, right? So we don't have a roadmap, as I said. If we had a roadmap, then we would disrupt our own roadmap. So I would answer program by program, and so we see a benefit. We do see a true benefit in contributing to the open source community because we believe that broadens those that can use it. It also allows for true international collaboration. And that international collaboration brings out the best of the global citizens and allows us to embrace more collaborators in a way that is challenging in most military development. And that's what I think is great about our nation. Our nation and our allies are an incredible strength. And so the open source community reflects that to a degree. And so if we can develop within an open source community and bring out the best of those developers around the world, then we stand as democratic nations to have an asymmetric advantage because we leverage, truly bring out the best of all collaborators rather than staying within small traditional military performers as well. But there is a role for the exquisite. And so I'll dodge the question by saying we don't have a true roadmap, but we do see opportunities that abound. This will be my last question. Does DARPA intend to use the space bacon acquisition strategy for future programs? So in true DARPA fashion, we now have an embedded acronym. The SBAA is the Space Bacon Acquisition Approach. And you will see the SBAA in future BAAs coming your way. We think there's a real role in some circumstances to leverage the Space Bacon Acquisition Approach. And that again is a short solicitation. Proposers respond with an abstract that we evaluate, fairly low bar to entry into oral solicitations, relatively large number of teams invited for what we call a phase 0 to write their proposal. During that proposal phase, we, DARPA, we the government, are able to better understand their capabilities as well as their intended design. And then at the end of that proposal writing phase, their proposal is submitted and rigorously reviewed, but it's reviewed within the context of all that we've learned over the past 3 months. And so we can award contracts. In fact, Space Bacon, those contracts were awarded, wait for it, within 8 days of the final source selection. 8 days. That's moving at the speed of relevance. And so we do see an opportunity to apply the SBAA approach to some programs that would benefit. It is not a panacea. There are clear downsides. It requires a great deal of bandwidth for the program manager and team. There are several other challenges, but it is a new tool in our quiver to use to try to change the world. So with that, I appreciate your attendance. Thanks sincerely. Look forward to hearing what we can do today based on what we couldn't do yesterday. Thanks sincerely.